Assalamualaikum and good day. My name is Muhammad AIMAN bin REDUAN with my teammates, which is Norhazifa and I'm FATIHAH AIMAN. Today I will be presenting about our system, which is the counting rice grain system. Introduction. Rice and wheat yields are mostly determined by 1,000 grain weight, which is an important metric for variety breeding and cultivation management. Counting grains is a necessary step in determining the weight of a 1,000 grain sample. Manual counting is tedious and time-consuming. Electronic counting devices are costly. Counting accuracy based on image segmentation processing is low, and the application are inconvenient. This study attempts to develop a system for fast rice and wheat grain counting based on the image given. The problem statement for our project is number 1, manual counting is time-consuming and tedious. Human eyes can become fatigued, resulting into errors. Number 2, how to recognize a common rice grain. And number 3, how to tell the difference between regular and not so regular sized grain. The objectives of our system is number 1, to count each rice grain individually. Number 2, determine the total number of grain of rice required to meet the standard quality. And number 3, to locate the exact normal grain of rice. The techniques that are used in our code are number 1, changes in intensity, which is contrast. Number 2, separation, which is edge detection. Number 3, image binarization. And number 4, conversion of color space.
Assalamualaikum warahmatullahi wabarakatuh. My name is FATIHAH AIMAN binti Muhammad YUSSUF. I will be presenting the methodology flowchart. So this is the summary of a flowchart symbols, which we have 5 symbols here: start and end, arrows, input and output, process, decisions, and their functions according to their symbols. So this is symbols that we will use in our flowchart later. This is flowchart of our project. Our project aims to do counting on rice grain. The flowchart starts with we need to read the rice grain image in a PNG format. If it is other than PNG format, then we need to convert it first. Then convert it to gray image, since we have to make it into a binary image later. Next, we have to generate histogram graph from the original image. The histogram graph is really important because from that graph we can get their threshold value. And then convert it to binary image and find and identify each rice grain image. Next, convert it to RGB to differentiate between the background image and also the rice grains. Next, find the area of the 50th component, find the grain with the smallest area, find the grain with the largest area, and label each grain. Then we have to print out the labeled grain image. Next, find the area of the labeled grain. If the area is larger than 100, then the total value will be added with 1. If not, then the total value will be added with 0. The process next is we have to satisfy both conditions. The conditions are area must be more than 500 and area must be lesser than 8,000. If both conditions is satisfied, then the standard will be added with 1. If not, then the standard will be added with 0. Then the process continue with searching if there is more grains in the image. If there are, then the process will be continue with find the area of the label grain. If not, then it will go to the print total number of rice grains, and then print the total number of rice grain that fits the standard, and then lastly generate the histogram of size grains, and then the process end here.
Assalamualaikum warahmatullahi wabarakatuh. My name is Harum. So I'm going to proceed with the code and demonstration. So we have 1 script file and 3 function files. So in the first 1 to 3 lines, I'm going to clear and close all the figures and workspace, and then assign the image into the variable. And then next we're going to read function call the function read.m file that done by FATIHAH AIMAN. So in this function, we will read the image and then convert it into grayscale, and then adjust the contrast and then convert it into the binary. And then back to the main file. We're gonna call identify object.matlab that done by AIMAN REDUAN. So in this file, function file, we're going to find and count the connected component in the binary image, and then visualize it, and then change it into the RGB. And then we're going to display the basic properties of the grain, and then hold the error measure for each grain of 50 components. And then we're going to label each rice grain. And then we're going to call the label object dot Matlab function. And then in this function, we're going to see the label of each object. And after that, we're going to see the label number of first object, and then until the last object, which is 50, and then determine the each rice grain area. And then we're gonna count the total rice grain. It's depend on the size. If the rice grain size is bigger than 300, we're gonna count all the rice grain, which is 50. But if we count the standard size, which is between 500 and 800, then it's gonna count about 40 rice grain. And then we're gonna display all the result, and then we're gonna run.
So we can see that the total number of rice grain that fit standard size is 40, and then the second one is the total number of rice grain, and then the graph number of rice grain, and then this is RGB image, and then this is how it count the rice grain, and then this image for increased contrast and the graph of the grayscale image.
Assalamualaikum, my name is FATIHAH binti YUSSUF. I will be presenting on result and analysis. So based on original image of rice grains, this figure, which is the left figure, shows the image after we have increased the contrast of the rice grain image. Contrast enhancement is one of the important steps, which it can improve the quality of an image, which have a narrow range of intensity value. While figure on the right shows the rice grain image in an RGB format. We converted it to RGB format to differentiate between the background image and also the rice grain image. Next, in this figure, we label all the rice grains founded with number. It counts on the number of the rice grain, 1 until 50, since we have 50 rice grains in the image. The upper message box displays the total number of rice grains founded, which are 50. And the bottom message box shows total number of rice grain that fits the standard 40, since we have defined the standard area of the rice grains earlier. Now for analysis, there are two graphs of histogram are generated. The first graph depicts the graph of a grayscale image. The graph is more biased to the left side. This is due to the image of rice grain that we use has more dark color compared to the bright color. The aim of this graph is to find the threshold value. Then the threshold value used for segmentation, which we can separate the background image and also the rice grain image. Next, on the right image, it is histogram of the graph number of rice grain versus size of the rice grains. The second graph shows a distribution number of rice grain based on im size. The highest is the size of the rice grain between 600 and 700, while the number of rice grain is between 20 and 25.
Next is the advantages of our system. The first added advantage is this system is easy to use. The second, reduce time used counting rice. And number 3, to determine the quality of the grain. Next is the disadvantages of our system. Number 1, sometimes the results that we get from the system are not that accurate. Number 2, rice grain cannot be close to one another when using our system. And number 3, cannot get results if we are given videos. So the system only accepts images or JPG and PNG. Okay, that's all for me. Thank you.